about percent yield. So in order for us to calculate a percent yield, we have to know what a theoretical yield is. We've been calculating theoretical yields, but we just haven't been calling them theoretical yields. Remember when we started with, say, 10 grams of a reactant, and then we calculated how much product we could get from that? The amount of product that we calculate is our theoretical yield. What that means is, if that reaction went perfectly and it went to completion and you didn't spill anything and everything was just, perfectly measured, that is theoretically how much product you can get. I like to think about that when I do make a recipe. It'll sometimes say makes 24 cookies. That's your theoretical yield. But then when you actually make them, I usually wind up not getting as many. Well, in the lab, your actual yield sometimes is not the theoretical yield. As a matter of fact, rarely is it ever your theoretical yield. So your actual yield is how much product you get in the lab. And so this is a value that has to be given to you. Percent yield is going to be the actual yield divided by the theoretical yield times 100. It is just like calculating your grade. How many points did you get? So your actual number of points divided by the theoretical number, what you could have got if you did it perfectly, times 100. All right, so I think the best way to do this is just to try a problem. So here we've got iron 3 oxide reacting with carbon monoxide to make iron and carbon dioxide. We're starting with 150 grams of our iron 3 oxide. We have plenty of carbon monoxide to make this reaction go, so it won't limit us. So what is our theoretical yield of iron? So let's go ahead and start with this problem. All right, so we have 150 grams of iron 3 oxide. So, whoops, I forgot to put my grams in there. All right, what we have to do is we have to convert this to moles. So a mole of iron 3 oxide, so 2 irons and 3 oxygens, it adds up to be, let's see over here, 159.7 grams per mole. All right, so that is moles of iron 3 oxide. Now, I don't have my balanced equation on this slide, but you can look back on the other slide. And we see from the mole to mole ratio that 2 moles of iron are formed for every mole of iron 3 oxide that is reacted. So now we are converting from our iron 3 oxide to our iron. So notice our grams cancel. If I had written it there, they cancel. The moles of the iron 3 oxide cancel. We have moles of iron, and the molar mass, we want grams for a yield. So a mole of iron has a mass of 55.85 grams. All right, so when we do this on our calculator, 150 divided by 159.7 times 2 times 55.8, the molar mass of iron, we come up with 104.9. We'll go to 3 sig figs, so 105 grams of iron. What we just calculated is called our theoretical yield. So there we have it. Nothing new here. We just are calling it a theoretical yield. We didn't do that in the last video. Okay, so we keep reading in the problem, and it says the actual yield, so you did this and you got 87.9 grams. What's the percent yield? Okay, to get the percent yield, we're going to take that 87.9 grams. That is our actual yield divided by our theoretical yield of 105 grams. We're going to multiply it by 100 and we will get our percent yield. And our percent yield is 83.7%. So there you have it. That's percent yield. We already knew how to calculate a theoretical yield. We just didn't know that it was called a theoretical yield. You're given an actual yield. Divide the actual by the theoretical, multiply it by 100. Voila, percent yield. Okay, so do the extra problem that came along with the PowerPoint, and we'll see you in class. Bye.